Hello and welcome to my presentation on the development of algebraic thinking in elementary grades. Okay, so I'll start with why I chose this concept. Well, one, to help my students become more prepared for junior high and high school. Two, to make sure I'm implementing the right curriculum for them to succeed. And three, picking a concept that will benefit me as an elementary teacher. So I teach third grade, so I thought learning the precursor to what they will have to know is important for me to teach in third grade. Okay, so what did I learn from my research? Well, in Article 1, it was called What is Algebra in Elementary School? It was really helpful because it taught me a lot of different things. Here are some facts and things I picked up from it. Algebra starts early in kindergarten when students are recognizing and extending patterns. I thought that was interesting to know because even at such a young age, you've already started your role in algebra. The word algebra can evoke feelings of anxiety, raise questions of appropriateness when discussed in relation to elementary school children. I love this because I think this is true. When we hear the word algebra, I think we panic a little and we think, oh, that's too hard, like I can't do that, but really they are doing it just more in a basic form. So I think making the word sound fun, whereas not stress them out or telling them wow, you're already doing algebra, I could think that could really push them. Another thing, algebra experiences in elementary school are essential to being a precursor to the more formal algebra in middle and secondary school. So just building that really important base for them. So the article talked about 4 major themes to be taught throughout K through 12. These themes were understanding patterns, relations, and functions, representing and analyzing situations, using mathematical models to represent and understand quantitative relationships, and also analyzing change in various contexts. The second article I looked at was a case study, and the purpose of this case study was to determine the impact of sustained early algebra intervention in third grade. So basically it's asking, does introducing algebraic concepts to younger age children help assimilate to high school? So in this case study there are 106 third graders, and they were from 4 different schools, but they were all from the same district. So the plan was that the students would be divided into 2 groups and were given different instruction. They wanted to see which group was more successful in algebraic problems at the end of the school year. So in group 1, we had the intervention group. There were 39 students. And then in group 2 was the non-intervention group with 67 students. So both of them were taught regular planned mathematics instruction. So they were all taught the same thing. But group 1, they had 19 one-hour lessons that was about early algebra lessons throughout the school year. So those lessons included, they were taught equivalence, expressions, equations, equalities, functional thinking, variables, and other concepts. So they wanted to see how this would change, or would it be different? Would we see differences between group 1 and group 2? So what they found was that the students in the intervention group, group 1, made huge progress on the pre and post tests. They also performed well above the other students. And the article basically suggests that introducing algebra was academically appropriate for the third grade students. Okay, so what can third grade teachers do to build good algebraic thinkers? Well, here are the TEKS associated with third grade algebra. So basically representing 1 and 2-step problems involving addition and subtraction with whole numbers. So using pictorial models, number lines, equations. I think just knowing the basics of all multiplication and addition and knowing how to represent them in a lot of ways is important for algebra. Also, same thing for B, but with multiplication and division. For C, describe a multiplication experience as a comparison, such as 3 times 24 represent 3 times as much as 24. So again, just really knowing the basics of all the operations. Determine the unknown whole number in a multiplication or division equation relating 3 whole numbers when the unknown is either a missing factor or a product. So I think this is dealing with variables and knowing when one of the products are missing, you have to figure it out, and using that inverse operation and trying to manipulate how to find the right one. And then represent real-world relationships using number pairs in a table or verbal expressions. And I'm going to talk more about that one in the next slide. Okay, so here is a question I pulled from a Release STAR test. It was a 3rd grade STAR test. And let me read the question to you. So it says, the table below shows the relationship between the number of red stars and the number of white stars Addison drew on different posters. So you have your table. It shows the number of white stars, and then there's the numbers that go along with that, and the number of red stars. So we have the input and the output numbers. So based on the pattern in the table, which number sentence can be used to find the number of white stars Addison drew if she drew 35 red stars on a poster? So I think this is important because it kind of shows like dealing with rules of algebra and trying to find the pattern and create like a number sentence and equation that goes along with the data table. So with my 3rd graders, what I would do is I would talk about the table, and I would talk about, all right, let's look at the number of white stars. So you have 7, 10, and 19. And then I would say those numbers are getting larger to get to the red stars. The red stars are larger than them. So I would tell my students we can either use 2 operations, addition or multiplication, because the numbers are getting bigger. Now, if we were going the opposite direction, we would use subtraction and division, but we'll get to that. So we would talk about, okay, well, let's see. Let's try multiplication first. So 7 times 4 is 28. So maybe the rule is times 4. Let's try 10. 10 times 4 would be 40, so it doesn't work. 19 times 4 does not make 40. So it would have to be addition. So we would subtract and figure it out. So now we know the rule is plus 21. So 7 plus 21 is 28. 10 plus 21 is 31. 19 plus 21 is 40. So now that we know the rule, they should be able to figure out that the inverse, going backwards, the problem does not want us to know. We don't know the problem. So we always put like a little question mark in the box. So we don't know that. So now we have to go backwards. And what's the opposite of addition? Well, it's subtraction. So they would have to subtract to find 35. Subtracting 21 would equal our number. So I think this relates to algebra in a way where it's really, really basic compared to what we do in high school, but I think it starts to show them that like we have to problem solve and we have to figure it out and we have to undo the problem and then redo the problem, and we have to know both ways. And I think this is where my role as a 3rd grade teacher, where I need to start with them. So basically, when talking about patterns and tables, I think for 3rd graders, the 3rd grade students can work on challenging themselves to find rules for the different data tables given to them. So they need to find the rules. Obviously, I wouldn't tell them the rules, so they need to problem solve to find that. The rule must match the input and the output of the chart, so they need to know how to go back and forth, and the students can be pushed to extend the chart. So I think when we're trying to differentiate, we can make sure the students go further and add on different numbers to the chart and create more to the table. And the discussions about the doing and the undoing, I think, are really important, because just like that question, it was tricky because they want you to find the rule, but they're also asking you which equation matches, which is the opposite of what they want. So it's important even for 3rd graders to know that they need to know how to go back and forth. Okay, another area that 3rd grade teachers could help build a good algebraic thinking, I think, is the commutative, associative, and distributive property. I think it's important that our students know when one expression is equal to another expression. Students need to become more flexible with their properties, and this will help when problems become more complicated. So when dealing with long equations and knowing what to do, I think if they don't have that good background in, you know, flipping numbers and being able to say, well, 3 times 2 is 6, 2 times 3 is 6, like, they can't be tripping up on those easy, simple equations. So I think as a third grade teacher, it's important for me to build that background for them so that in the future they can build off that and do more complicated problems. Another area that I think is important is to work on the equal sign. I think we need to make sure that students know that the equal sign is dealing with relationships, and it's a relational symbol, and it indicates that the two quantities on either side represent the same amount. I think students think that it's an action when they should be understanding that both sides are equal. And I think that the best way to teach this is basically to just have discussions about this with your classroom and showing them, like the example one here on the bottom, like showing them, pictures, like putting this up on the overhead and just saying, all right, guys, like, what do you think about this? Is this true? Are they equal? Why? And just having students like talk it out, hearing other students talk about it, I think that's really important for them to build an understanding. Okay, and then overall, here are some rules to hold on to as the school year goes by for third grade teachers. I think to be open-minded and never to use the word always. I think that's something that's stuck with me this semester. I know we always want to say, like, always do this, and this will always be like this, because it will be for the period in third grade that they have you, but I think if we stay away from that word, it could help clear up some misunderstandings in the future for them. Ask lots of questions and prompt lots of discussions. I think, like I said earlier, discussions and hearing things and, having them dig deep into their math will really help them figure things out. And allow students to productively struggle with lots of time for problem solving. So giving them time to hash things out, to struggle a little bit, and to figure it out on their own. I think sometimes as teachers we rush to give them the answers, and it's not good for them, because then they will never have the stamina to figure it out and problem solve and solve the problem on their own. And last but not least, here are my references to Articles 1 and 2 that I referred to earlier in the presentation. I hope you can take away something from my presentation and that you enjoyed it. Thank you for listening.